of America, so we thought we would give her a little bit more time. So welcome to Nimesh Mistry from University of Leeds. So here is Nimesh, and three things about Nimesh. Well, I can say I know Nimesh very well, and it's really been apparent over the last few years that Nimesh is doing lots of really fantastic things here in UK higher education. That's really showing he's a leading voice here and internationally. So I always follow his work very closely. He's what I call MISA royalty because he was part of the MISA program. He was actually co-chair of MISA in 2018. And he does a lot of work. His own background is organic chemistry, but as you'll see, he does a lot of work in thinking about competencies, active learning, and so on. And I just rubbed the picture from his Twitter feed because I know some people in the audience love sheep. So here is a photo. Nimesh lives in a very beautiful part of the world, and here's a photo of him doing a daily walk during lockdown. So Nimesh, I'll pass over to you. We're recording now. If you can just say if you don't mind people tweeting your slides or not, and then we can go. And I'm going to get your slides and share them in the chat.
Okay, yeah, no problem. Please feel free to record, or take screenshots or anything. I don't mind with any of those things at all. And yeah, thank you, Michael, for the introduction. I think the sheep. Well, I think I like the sheep much more than the sheep like me. I think I tend to get on their nerves when I try and take photos of them as I'm going on my daily walk. So hopefully you can all see my slide now. It's all on the screen for everybody. Yep, and I do apologise for not being able to share the slides earlier, but I've sent it through to Michael, so hopefully it will come up onto the chat, and you'll all be able to have a PDF copy of those. So yeah, thank you again to both Michael and Aisling for the invitation to speak at today's MISA. What I'm going to talk about is the use of factor analysis as a tool for analysing survey structure. And this is a technique that I've only recently learned how to use in the last couple of years or so, and it's a really useful technique of looking at how items that you have in a survey can be connected together. And so what I'm going to be doing, trying out the next slide, is what I'm going to be doing is presenting this at quite an introductory level, so almost like I'm talking to myself from a couple of years ago. That's how I'm going to introduce this particular method. And I'm also going to be using my own research as the context for describing these methods, because essentially that's kind of how I know or understand these methods. It's through the lens of using it in my own research. And because of this, I see factor analysis being intertwined to when you think about how you design a survey to measure particular aspects of student learning, and you think about how items are come together to measure more broader aspects of student learning. So I'm actually going to present this into two parts, where I start discussing, for the first part, discuss survey constructs and how you can design surveys so items are related to one another and can form factors, and before then moving on to the second part, where we actually discuss the use of factor analysis to actually prove and verify that the surveys actually are coming together to form factors in this particular way. So what I'll do is I'll just start by introducing the two projects that I'm going to provide as context for talking about factor analysis. The first project is a project that I did with my colleague Stephen Gorman, where we designed a laboratory skills survey because we were interested in measuring the levels of lab skills that our students had, and we wanted to see how they were developing as the students were progressing through the course. So what we did was we designed an instrument that would measure a variety of laboratory skills. So there's 24 skills in total, covering areas such as practical technique and other areas like maybe the student's ability to problem solving in a laboratory context as well. And what we asked students to do was to kind of self-assess their ability to perform of their sort of knowledge, experience, and confidence of each skill from a scale of 1 to 5. And we first became aware of this methodology from actually the work of Marcy Towns and Michael Seary as well, when they were sort of developing sort of lab skills through digital badging. And this is one of the methods that both of those people and their groups did sort of independently to measure lab skills. So it seemed quite useful to us as a method for measuring the development of lab skills. What we recently published was our data that we had on students' sort of development of lab skills when they first started at the beginning of the university, at the start of the course with us. It also talks through the validation of this instrument as well, with which factor analysis was one of the methods that we used. And this was just recently published in SERP, so it's still an advanced article at the moment. The other project where we've been using factor analysis is a project that has just started this year, and I've been doing this with a project student of mine, Owen Williams. And what we wanted to do was to measure the levels of students' academic motivation in sort of STEM subjects, and we wanted to see how they were sort of developing as they were progressing through the course. So for this particular project, what we were doing was actually taking an off-the-shelf instrument called the Academic Motivation Scale. It was designed by Valorand almost 30 years ago now, and it's designed to measure sort of 7 types of intrinsic, extrinsic, and a motivation as well. And the way that this particular instrument works is that students have, the instrument has a list of statements, a list of types of motivations, reasons why students might be interested in studying onto a university or college, and what the students do is they sort of, if a statement sort of corresponds to their own sort of motivation, then on a scale of 1 to 7, they sort of indicate how much that statement agrees with their own sort of motivation. Okay, and this is one where even though it's a validated instrument, we have still used factor analysis to sort of help us analyse our results from the use of the academic motivation scale. So far, we've used the AMS survey on students right at the beginning of at the start of university, and then we're hoping in the future to sort of continue to use the AMS survey on these students. We're just interested to see how their sort of levels of motivation changes as they go through the course. Okay, so that's the kind of context that I'm going to talk about: survey design and factor analysis as well. Okay, so I'm going to give an overview of how we can think about surveys and learning instruments sort of being constructed. So going beyond just having survey items that you use to maybe measure learning or an intervention that you've implemented into a course, where instead of just having 1 or 2 items and they're kind of randomly sort of implemented into a survey, we can think a bit more deeply about how we design a survey so that items are sort of related to one another, and from doing so, we could be measuring factors to see if we're measuring something a little bit more deeply, or if something that we might struggle to measure a little bit more directly. So, for example, we might have items in the survey where we're saying, I enjoy chemistry, or I think chemistry is great, or I think I hate chemistry. Okay, and if we do this, then we are actually having items which are similar to one another, and therefore we could sort of perhaps are detecting an underlying theme of an aspect of student learning if we're sort of designing our survey in this way. And then this all comes together in sort of a more general sort of construct, sort of aspects, broader aspects that we're sort of trying to sort of gain knowledge of through the survey. So in terms of the reasons of why we would want to have maybe multiple items that are correlated together, that we could sort of maybe use a technique like factor analysis to see that they're correlated together. Essentially what we're trying to do here is we're trying to measure a concept through our survey called construct validity, which in a nutshell is all about making sure, one of the things we want to make sure we're doing in our survey is we want to make sure that we're measuring what we want to measure. And so having multiple items that sort of are similar or related to one another is a useful technique to use in sort of survey design, because it can add to the validity that you are measuring what you want to measure. So for example, so I mentioned before, I really enjoy chemistry, strongly agree. I love chemistry, strongly agree. I hate chemistry, strongly disagree. Okay, we would expect students to be measuring these items in a similar way, and therefore that adds strength to the argument that we are actually measuring what we want to measure. I like to think of it also as being similar to the process of a triangulation that you can use to track someone and where they are using sort of mobile phone signals. So you take sort of 3 sort of data points and that kind of hones in to say that, this is exactly where this person was as well. And that's kind of similar to what we're doing with items when we design a survey with multiple items in this way. We're kind of honing in onto this aspect of student learning, and factor analysis can sort of reveal that. Another reason why it's useful to have multiple items in designing a survey in this particular manner to sort of reveal sort of factors is that it can be hard to directly measure an aspect of student learning. So for example, it could be hard to, if you ask students on a motivation scale, if they had high levels of intrinsic motivation, then I'm not sure that students will know how to answer that properly. I'm not sure that many students would even know what intrinsic motivation is, and that's going to affect the validity of the instrument. It's going to affect the thing that you're trying to measure, and making sure that you are measuring what you want to measure. So instead, what you can do is you can indirectly measure that sort of construct. So you could have sort of multiple statements relating to intrinsic motivation, for example, and then through factor analysis, you can show and prove that you are measuring that type of motivation, and actually report the levels of that type of motivation as well, and then factors more generally. And the third reason why it can be useful to have multiple items sort of measuring sort of an aspect of student learning is because surveys are open to errors, human errors, by how students answer the survey. So if, for example, one particular student misreads one of the items, interprets it differently to how you intended it to be answered, then that's going to affect that particular result for that particular item. But if there are other items in the survey which a student does understand more similarly to how you expected it to be answered, then you're still getting that data from the students, and it cancels out that interpretation. Or if multiple students are analysing or interpreting that particular item in a different way to what you expected to, then factor analysis will reveal that, So you can choose not to include that particular item in terms of how you report it, and use the other items instead to measure that particular factor, that sort of learning construct. Okay, so here's the example of designing a survey to think about, you know, how items come together and how they can come together to form factors and learning constructs. So in the laboratory skills survey, there were sort of multiple areas. I mentioned practical skills was one of the areas in which we were trying to measure. Practical techniques was one of the areas which we wanted to sort of measure how well students have developed their various practical techniques. So one of the things we did is we split this down into various different particular lab skills. There were 6 in total, but I'm just showing 2 here for simplicity. Sort of purifying a solid by recrystallization, purifying a liquid using distillation. And what we actually got students to do to sort of make sure that we were measuring these skills in a more detailed manner was to specifically measure sort of students' sort of knowledge, experience, and confidence of doing each of these sort of skills. And then through sort of factor analysis, if we can show that these particular items are sort of factoring together, the way in which students are answering these questions do have a degree of correlation, then we can say with confidence that we are measuring students' perceived ability to perform these skills, because it's a self-assessment tool. In terms of the academic motivation scale, okay, we haven't designed this instrument ourselves, but it's really important in how we analyse the data to understand how the survey was developed. And so it measures, as I mentioned, broadly speaking, 3 types of intrinsic, extrinsic, and a motivation. But it was also designed to break down intrinsic motivation into these sort of 3 types of intrinsic motivation. We have intrinsic to know motivation. This is where students are motivated for studying because they're really interested in gaining new knowledge about the subject. We have students who are interested in studying because they really enjoy the experience of sort of learning about the subject. That's what we call intrinsic to experience. And for students who enjoy sort of applying and accomplishing things in the subject, then we have intrinsic to accomplish. For extrinsic motivation, we have identified regulation, where students are interested in learning about subject material, but where it's related to a particular career that they have in mind. Introjected regulation, where students are interested in studying to achieve good grades, and then external regulation, where students are interested in studying because they think it will help them achieve a better career, a better salary later on in life. Okay, and then finally we have, as a 7th type of motivation, we have students who have absolutely no motivation at all for studying the course. So I mentioned before, it could be quite hard to directly measure these types of motivation. And so what the survey is designed to do is it has 4 items relating to types of motivation that relate to each of these 7 types of motivation. And so through factor analysis, if we can show that all of these 4 items, or all the 4 items relating to each motivation factor together, then rather than reporting the results of each of the items individually, we can collectively report how much motivation each of these types of motivations students actually have. Okay, so what I'm going to do next is just sort of talk you through external regulation and show you the 4 items, just to show you the kind of things that I'm talking about, where you can design items to measure something that is harder to directly measure. So the first item on the academic motivation scale for external regulation is this one here, because with only a high school qualification, I would not find a high-paying job later on. In order to retain a more prestigious job later on, because I want to have a well-paying career, and in order to have a better salary later on as well. So we can see that all of these statements are quite similar to one another. So you would hope that students answering the AMS survey will be answering them in a similar way. They don't have to be exactly the same. So we can see that statement 4 talks about salary, statement 3 talks about career, and statement 1 has sort of both of those things included. Okay, so it's just an idea, an overview about how, before we go into sort of using factor analysis, it's quite useful to think about actually designing the survey. So items are similar to one another, could perhaps factor together to sort of learning. Okay. So at this point, this kind of concludes the first part of my talk. I thought it'd be useful for you to have a go at actually designing survey items that are similar to one another. And what I thought you could do was actually have a go at designing items that you think would come under intrinsic knowledge sort of motivation. So motivations where students are interested in studying the subject or on your course because they want to gain more knowledge of the subject area. A reminder of the academic motivation scale down here. What you want students to do is, if they agree with this type of motivation, then they want to be rating it quite high, sort of around about 5 to 7, or if they don't, sort of between 1 and 3. Okay, so please have a go at doing this. Use the chat box to sort of write your statements. I'll try and figure out how to get the chat box open onto my screen, but if I can't do that, Michael, it might be useful just to, if you could help me just read out some of the statements, and then I'll reveal what the actual statements are in a few minutes' time. Okay.
So in the top right-hand corner, you might see an escape full screen or something, and that will show the chat box on the right-hand side. But if you don't see that, I can...
I did bring it up. I'll give it another go.
Or alternatively, if you... Oh, no, you have to see the chat.
I've got the chat up. Yeah.
Yep, great.
Well, here we go. Okay. Okay, so why a 7 item scale? I think that's just I think I can't speak for Valeron, but I think that's how they wanted quite a large scale, so they could sort of distinguish. But broadly speaking, you can see the sort of descriptors above the scale. So if there's averages, I think they wanted to distinguish between but be able to better distinguish between sort of average motivations being above 5, being around about 4, or being 1 to 3 compared to say a 5-point scale. So I think the way the scale works is, if you've got an average motivation above 5, then you can say that students have high levels of that motivation. And between 3 and 5, they've got average levels of that motivation, and below 3, they've got low levels of that motivation.
So just so I'm clear, we're asking people to come up with 2 or 3 related questions, or a question that would...
Yeah, so, just if you could think of statements where a student would say, I have, that relates to having intrinsic motivation. So, for example, there's a good one here from Jared: to learn things that I am interested in. That's a good one. You would expect students to go, if they have intrinsic motivation, to say, yes, I have that here. So I am interested in the pursuit of pure knowledge. Learning science for its own interested me. Yeah, those are good ones. I'm fascinated by finding out how things work. I enjoy learning new things about the subject as well. Okay, so that's good. I think items are coming in here now, which I think are would relate to intrinsic motivation. So it's not as easy as it sounds, to come up with distinct items that are still related to one another. Okay, great. Thank you very much for participating. So I'm going to sort of move on to the next slide. So I'm just going to show you what is actually in the academic motivation scale for this type of intrinsic motivation. Get back. There we go. Okay. Because I experience pleasure and satisfaction while I learn new things, for the pleasure that I experience when learning new things, for the pleasure that I experience when broadening my knowledge in subjects that appeal to me, because my studies allow me to continue to learn about new things in the subject that interests me as well. Okay, so we can see that there's some of the things you created are similar to some of the things in the academic motivation scale, and so there's a good a high degree of chance that actually students would answer these items and your items in the same way as well. Okay, so just bear with me for one second. I'm just closing down the chat. So okay, so that concludes kind of the first part of designing the learning instrument. So we have items that could be sort of factoring together. Then we sort of run the survey. We get student sort of data, and once we have sort of student data, then we can actually use factor analysis to actually analyse how the students have actually answered the surveys, and whether or not items have come together either as you intended it to, or in other ways that were not expected, in which case you can infer new things from your survey and in your instrument. Essentially what we're doing with factor analysis is we're sort of doing the reverse of the survey design. We're seeing, are there similarities in the way that students have answered items, and can we identify the underlying relationships between sort of measured variables. Again, it's answering that important question: are we measuring what we want to measure? So there's two types of factor analysis, or certainly two types that I'm aware of. The first type is called confirmatory factor analysis, and this is where, in this particular method, you create the factors that you expected the survey items to come under, and then you take the students' data and you test it against this hypothesized model. Or there's exploratory factor analysis, where you make no prior assumption about how the items that are factored together. You input the students' data, and you see what factors are created. So you see whether or not the factors created sort of align with your survey design, or whether new factors are created. And because in my own research and those two projects, I've been using exploratory factor analysis, this is a method that I know I'm most familiar with. So this is the one that I'm going to talk about in more detail and show you when I show you my results from my use of factor analysis. It will be using EFA. And this is a very basic, very broad overview of how the method works. As I mentioned, this is a kind of introductory introduction to the methods. But essentially what you start off by doing in exploratory factor analysis is you input the items that you want to see how they sort of factor together. So this could be all the survey items in your instrument, but they don't have to be. You can choose the items that you want to. And what happens is first is you sort of generate the factors through principal component analysis, and it's rotated through the items to make sure that, you know, as many, you get all the factors being generated from your items. And then once the factors have been created, then against each factor, the items are correlated to see how strongly they do correlate within each factor. It's what we call factor loading. And then we sort of, we can see how strongly each of the items are correlating into this each factor. So when we get sort of values that are close to 1 or close to -1, so for example, if you had a factor related to enjoyment of chemistry and you had one statement saying I hate chemistry, there would still be a correlation, but it would be an inverse correlation to perhaps some of the other items. And that's how you could get values sort of close to sort of -1. If you get strong correlations, then we can say that these items are factoring together and they're relating to measuring a particular learning construct. If the values are close to 0, then we say that there's no correlation. As a general rule of thumb, correlations above 0.3 or below sort of -0.3 does indicate that the items are factoring on that particular factor. But just like any statistical method, it needs human interpretation. And so you're going to see, firstly, I'll show you, one example of EFA data that works really nicely. It's not too hard to analyze and interpret, but then the second set of data I'm going to show does need a lot more sort of human interpretation. And so the first set of data I'm going to show is from the laboratory skills survey. So this is just a sample of the data, not necessarily all of the sort of EFA data, but you can still get the picture from this. So what we did is we sort of inputted, sort of say, for example, these 9 items, these skills, into exploratory factor analysis, and from these 9 items, these sort of 3 factors were created. And we can see that in the first factor that we've got sort of strong correlation with these 3 items here, all relating to distillation. So we can say with some confidence that this first factor is measuring students' ability to perform sort of distillation, which is what we wanted. That's how we designed the survey. So we can say with confidence that with the EFA that we are measuring this aspect of students' ability to perform that particular skill. We can say with the second factor that we're measuring students' ability to perform sort of a liquid-liquid extraction, because again, those items are all factoring together into this second factor, and then the same thing with a recrystallization as well with the third factor as well. So we can see how it can kind of confirm what you were trying to sort of achieve when you were designing the sort of.
Yeah.
So this is an example of nice data, everything working sort of perfectly. I'll show you the data that we got from the academic motivation scale survey, which wasn't as nice. So when Owen sort of analysed the AMS data that we had using exploratory factor analysis, what he found was that 4 of the factors were created for 4 of the types of motivation. So all of the external regulation items, for example, they all factor together onto their own factor. The same with these other 3 types of motivations. It was but however, with the intrinsic motivation items, they didn't all clearly sort of factor onto their 3 separate types of intrinsic motivation. Instead, what we found was that for the accomplish type of intrinsic motivation, 3 of those 4 items all sort of factored together. And then we found that a lot of the other intrinsic items all loaded onto the same factor. So I'm going to show this data onto the next slide. Okay, so in the first column here, we have the types of intrinsic motivation. So we can see all 4 sort of knowledge intrinsic motivation items are all together. So those are the 4 statements that I revealed sort of earlier. We found that they all factor together onto this one factor, but then so did 3 of the experience intrinsic motivation items as well, with good correlations, not far off the knowledge items as well. That 4th accomplish intrinsic motivation item, which didn't sort of factor with the others, in fact, loaded onto this same factor as well. And then this experience item at the bottom actually comes, it didn't load onto this particular factor, it's below that 0.3 threshold. A separate factor was created for this instead. So this is an example of messy data that needs more human interpretation. And so as a kind of final discussion task, a discussion topic, I'm quite interested to see what you think, how you think this data should be analysed. So do you think, for example, it would still be okay to report the intrinsic knowledge items separately to these other intrinsic motivation items? Or do you think at least sort of these 3 experience items should be reported together? Do you think it's okay to report the 3 accomplish items that came under their own factor together, or do you think we need to incorporate this particular accomplish item as well? And finally, or as another sort of discussion point, do you think this final experience item at the end needs to, can be included with the other experience items, or do you think it should be considered separately as well? So I'll try and get my chat back up, so I've just closed it, but I'd really be interested to see, what are your thoughts on how this should be analysed? We've got a few minutes until the end of the talk, so this is kind of the final thing that we're going to do. Again, once I get the chat up, I'll try and reveal, see what your thoughts are in here, and I'll reveal my thoughts as well before concluding.
Just to say, Nimesh, if you can wrap it up in 2 or 3 minutes or so.
Yeah. So there's time for people to see.
Sure.
What people. Yeah. So from Emma, should you use confirmatory factor analysis to confirm the construct? That's a really good idea, actually. It's not something we tried yet, but I think that is a good idea. So create the factors with each type of motivation and see how well the data fits against that. I think that's a good idea. So Patrick, is it about the interpretation, about how students are reading or reading these items? That's a good point. So something we did, what Owen did, after we got these results, is he got some students to read out the statements and talk about how we understood those. And so if you look at that sort of experience item at the bottom, it talks about communicating subject knowledge, whilst the other 3 experience items don't talk about that at all. So it's kind of understandable why students might have answered that experience item differently as well. So yeah, just some further comments about confirmatory factor analysis. So confirmatory factor analysis with new data. So do you mean sort of new data that's different to this particular set of data. Is that what you mean? Okay, yeah, okay, so that's okay, so cool, yeah, so with a new set of data different to this. I must say one of the things we were thinking about was, because as I mentioned before, we're kind of measuring their motivation as students are progressing through the course. We were going to sort of get a new set of data by measuring, using the scale again, with these students once they've gone into their second year of study, and then we were going to sort of do some more analysis. We were going to do more factor analysis. We were thinking of EFA, but we didn't think of confirmatory factor analysis. But yeah, definitely we can look at doing CFA as well.
I'll ask you to wrap up now, Nimesh, because we'll need to continue the conversation in the chat.
Yeah, okay, great. Well, thank you very much for that input. So I'll just sort of, whoopsie daisy, I've expanded the chat. How the hell do I get out of this? Okay, I'm back. So I'll just tell you thoughts, things where I think we've got some confidence. I think definitely could sort of remove this sort of experience item because the bottom experience item and not report it alongside the others because it's clearly not factoring the others. What we're less clear about is whether or not we can sort of communicate knowledge and these other experience items separately, or we should include them together. But thanks to those sort of input we just had, maybe we'll sort of go with getting some more data and sort of looking at confirmatory factor analysis as well. Okay, so so thanks very much for your attention. I'm trying to get up the last slide, but just want to say, if it doesn't come up anyway, just to conclude, hopefully you got an idea then of how we can design surveys to bring items together to form sort of factors, and then also use sort of factor analysis to sort of reveal, how items are coming together to form things, sort of to give you greater confidence about things that you're trying to measure or things that you're trying to measure indirectly. And you've seen, sometimes you get sort of data that's quite easy to interpret and confirms what you wanted to design in a survey. And as you can see here, sometimes you get messy data as well, which needs a little bit more sort of human interpretation as well. So thank you very much.
Thank you, Nimesh, for taking us through a survey of your survey approaches. Really interesting, I think, to get people thinking about surveys and survey design. So we will move swiftly on. So